And so our next presentation is from Daniela Dominguez from the University of British Columbia. And Daniela is going to be presenting evaluating the sustainability of black soldier fly larvae on laying hen feed using LCA or life cycle assessment. So take it away, Daniela.
Hi, thank you. Okay, good day, everyone. As it's been mentioned, my name is Daniela Dominguez. I'm a first-year master's student in sustainability at UBCO, and I'm also part of the food system PRISM lab, working under the supervision of Dr. Peltier. As it's been said, I'm going to talk to you about my research project, which is a life cycle assessment to evaluate the environmental sustainability of the use of insect meal for laying hens feed. So as we know, the agricultural sectors are facing serious challenges to meet the growing demands of food in a sustainable way. There are two major areas of concern in the global food systems. One of them is the livestock industry, which is responsible for a large share of environmental impacts. However, within the context of livestock, the poultry sector has been found to be the most efficient due to the nutritional qualities of poultry products and because it requires less use of resources to produce. In Canada, the egg industry has also been increasing over the past decades, but it was found that the environmental impacts have been decreasing due to the optimization of activities at a farm level and along the supply chain. However, the production of poultry feed is a key contributor to the environmental impacts of the poultry industry, which compromises the sustainability of the products. And therefore, there's a need to produce feed in a more sustainable way. Another important environmental issue in the food sector is the large amounts of food waste that is generated globally. It is estimated that 1.3 billion tons of food is lost or wasted every year. And this presents several social, economic, and ecological challenges due to the waste of resources along the supply chain, such as land, water, energy, labor, and fertilizers used in the food systems. And another environmental issue is related to the greenhouse gas emissions from the supply chain losses, as well as the gases that are generated by the food decomposition when it is disposed into landfill. So one promising solution for these two challenges is the production of edible insects as a new source of protein due to their higher feed conversion efficiency, a lower use of land, and a lower greenhouse gas emission from the production. Additionally, studies show that insects, specifically the black soda fly, has the potential to become a more effective organic waste treatment because the bioconversion process can recover nutrients from different types of organic wastes, such as food waste, food byproducts, or animal manure. So by reincorporating these wastes back to the supply chain, the process could become a circular economy strategy that addresses two of the major food sustainability challenges by producing high valuable products. However, this technology is still new and there have been few studies regarding the environmental impacts at a larger scale of production. So there is still unclarity as to whether or not this may present significant sustainability benefits. So therefore, the main goal of my research, as I mentioned, is to conduct a life cycle assessment to evaluate the sustainability potential of the production and use of black soldier fly meal for laying hens. So for my project, I am working with the company EnviroFlight, which is one of the few black soldier fly producers in North America. They opened their pilot plant in 2009, and then in 2019, they opened the first US commercial scale facility of black soldier fly. And they currently offer 4 different products. The pure protein, which is a black soldier fly meal, cold-dried larvae, oil, and frass. So using the EnviroFlight pilot and commercial facilities as a basis of my case study, the specific goals that I will try to meet are, first, to evaluate the current environmental performance of both the pilot and the commercial scale facilities, to find if the commercial scale presents a significant advantage over the small scale production system in terms of efficiency. Then I will focus on trying to identify hotspots or phases from the commercial scale production, which have the potential to be improved by the use of alternative technologies in terms of energy efficiency, such as heat recovery ventilators or the use of renewable energy sources. And finally, I will aim to determine how the use of black soldier fly meal can become a sustainable feed input for laying hens compared to the conventional feed ingredients. So as previously mentioned, LCA is a quantitative tool that is based on ISO 1444 standards for environmental management, and it is used to evaluate the potential environmental impacts of a product system throughout each stage of its life cycle using multiple criteria. These are some of the basic impact categories that are commonly applied in LCA and that I will be assessing as part of my scope. And this flow diagram represents the black soldier fly meal production, which is the main part of my project. And it includes the larva production from breeding and rearing stages to the processing of the larvae. And the outputs of these production systems are the black soldier fly meal, which is the main product, and then the co-products, which are the crude oil and frass. So lastly, I'd like to share with you what the next steps of my project are. Currently, I'm working on the data collection phase, collecting data from the company EnviroFlight. So once I complete my data inventory, I will start modeling the product systems, following by the impact assessments, and then the modeling of the different scenarios by using, and I will be using the Open LCA software. And I will finalize my project with the interpretation phase, which will include the conclusions and recommendations about the use of black soldier fly meal for the poultry industry. So that is all for me. Thank you. If you have any questions, please let me know.
Thank you, Daniela. Very interesting. Again, folks, if you have any questions, please put them in the question and answer box. So I have a question. I've toured a black soldier fly production facility, and I'm just curious, are they all fairly similar, or are there differences in production systems that might affect your interpretation or your conclusions, given that you're studying just at one location right now?
Yeah, the main differences are the production scales and the technology that are applied at a larger scale. So they do have different machinery for both production sites. So that will be the main difference in the energy efficiency and the production scale.
So do you anticipate that, in the system that you are doing your evaluation, you'll be able to extrapolate to some of those other systems, or will it be just specific to that type of system that you're working with?
So there, I have got some preliminary observations. So in terms of energy efficiency, the larger scales seems to have an advantage on that. But as I mentioned, I will also be modeling how to improve that efficiency in terms of energy consumption by applying different types of technology. So I will be performing the impacts of the currently technology that has been applied, but also how that could be improved.
Perfect. Well, I think that is all of the questions. Thank you so much, Daniela. Very interesting presentation.
Thank you.
And oh, I see one just popped up. Before we let you go, one more question. From the standpoint of sustainability of the protein as an ingredient, there is a difference between the economic and environmental sustainability. How do you intend to balance these, as current black soldier fly products are simply not cost competitive with plant protein?
Actually, right now I'm just focusing on the environmental sustainability. I'm currently evaluating if I should also focus on the economic part, because I do recognize that economic sustainability is a essential part in the sustainability overall. But right now I'm just focusing on the environmental.
Yeah, and the economics kind of are relative in some ways, right? As the pressure on our environment becomes greater, the economics are modified. I guess I would say, right? They change. So right now it might not make sense, but it might in the future. So it's good to be doing this kind of work. So great. Well, thank you very much, Daniela. And